Our sun is a powerful force of nature. It's a giant ball of hot gas, fueled by nuclear fusion. While it provides us with light and warmth, the sun can also unleash bursts of energy. We call these events solar storms. Imagine them as the sun's way of throwing a cosmic temper tantrum. These storms are a reminder that even our seemingly stable star is a dynamic and ever-changing celestial body. Solar storms originate from the sun's magnetic field. This field is like a giant web of invisible lines that crisscross the sun's surface. Think of it like a rubber band. Twist it enough, and it eventually snaps. Similarly, when the sun's magnetic field lines get too tangled, they can break and reconnect, releasing tremendous energy. These magnetic disruptions can create a variety of solar storms. Two of the most important are solar flares and coronal mass ejections, or CMEs. Understanding these phenomena is crucial because they can have significant effects on Earth and our technology. Solar flares are sudden, intense bursts of radiation from the sun. They're like giant explosions that release energy equivalent to millions of hydrogen bombs. But instead of heat and sound, solar flares release light and radiation across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. The process that drives these flares is called magnetic reconnection. Imagine two magnetic field lines approaching each other. They get so close that they break apart and reconnect in a new configuration. This reconnection releases a tremendous amount of energy, much like snapping a rubber band releases stored energy. The energy released in a solar flare travels at the speed of light. This means it reaches Earth in just over 8 minutes. While the light from a flare doesn't harm us, the X-rays and gamma rays can disrupt radio communications and GPS signals. Coronal mass ejections, or CMEs, are another powerful type of solar storm. Imagine 1 billion tons of superheated gas called plasma being hurled into space at millions of miles per hour. That's a CME. They're like giant bubbles of plasma, launched from the sun's corona, the outermost layer of its atmosphere. CMEs are often associated with solar flares, but they can also occur independently. When a CME erupts, it blasts a huge cloud of plasma into space. This plasma carries with it a piece of the sun's magnetic field. If Earth happens to be in the path of this magnetized plasma cloud, it can trigger a geomagnetic storm. These storms occur when the CME's magnetic field interacts with Earth's magnetic field. The results can be both beautiful and disruptive. On the one hand, we get stunning auroras, the northern and southern lights. On the other hand, geomagnetic storms can interfere with satellites, power grids, and even radio communications. Solar storms, while fascinating to observe, can pose significant risks to our technology-dependent society. CMEs in particular can have a profound impact on Earth. When a CME's magnetized plasma cloud hits our planet, it can compress Earth's magnetic field, triggering a geomagnetic storm. These storms can induce electric currents in power lines, leading to widespread blackouts. Satellites, crucial for communication and navigation, are also vulnerable to damage from solar storms. In fact, in 1989, a powerful geomagnetic storm caused a major blackout in Quebec, Canada, leaving millions without power. One of the most famous examples of a powerful solar storm is the Carrington event of 1859. This massive solar storm caused telegraph systems worldwide to fail, with some operators reporting electric shocks and fires. If a similar event were to occur today, the consequences to our technology-dependent world could be catastrophic. Understanding and predicting solar storms is crucial for mitigating their potential impact. By studying the sun and its behavior, we can develop better forecasting models and take steps to protect our critical infrastructure from the sun's fury. Stay informed, stay curious, and never underestimate the power of our nearest star.